Okay, so we're going to talk about section 1.6 about graphing the linear equations. So linear equation in three different forms. First form is slowly the second one. Y the second one is in the slope form. Y minus 1 equals slope times x minus x1. We have the third form, standard form. Which is ax plus by equals c. So we're going to learn how to graph the linear equation in either one of these forms. Okay, so graph a line using any linear equations, three different forms. Now we're going to learn how to graph it using slope-intercept form, also the standard form. Slope-intercept form y equal to max e. Standard form will be ax plus by equals c. And the third form is a point slope form, so y minus y1 equals slope times x minus x1. So I'm going to get into the techniques of graphing each one of these. Okay. So first of all, let's look at this. We have to use three different methods for graphing the equations. Using slope-intercept form, using xy intercept, or using the point slope form. All right, and which points used to graph xy intercept? The answer to this would be the standard form. Which is ax. This is the most convenient to use xy intercept in graphing the standard form of the linear equation. And then also we got to be flexible in terms of determining which method is the best for each different scenarios. I'm going to get into each one of these in details. So slope-intercept form first, y equal mx plus b. We see m is the slope of the line, b is what we call y-intercept. Those two are the most important elements in the slope-intercept form. Second one is the standard form. You see something ax or by equals c. Here a, b, and c are integers. A is greater than 0, it must be positive. Right? And the third form is the point slope form. Okay, so given slope and point x1, y1, and we go from there. And you can always turn the point slope form into the slope intercept by do a simple conversion and isolating the y. So let's look at the quick cheat sheet, right? If the equation is in the standard form, graph using the intercepts, xy intercepts. I'm going to show you the detailed calculation in a little bit. And if the equation is the slope intercept form, then graph using slope and then the y intercept, or using the t-table instead, if that's easier for you. And if the equation is in neither form, then choose whichever method you prefer or you feel comfortable working with. Okay. Now let's take a look at example. Let's say it's about telephone costs. So in the community, the monthly cost of the local telephone service is $5 per month, and this is like fixed monthly cost. Plus 25 cents per call. And so this is what we call variable cost per unit. Variable cost. Now write a linear equation that gives us cost C for a person making n calls, right? Okay, so first of all, we know that the slope here, variable cost per unit, it's what we have a slope. So slope equal to 25 cents, so it's 0.25. Okay. And then the y-intercept, this $5 is y-intercept b equal to 5. So basically we have the slope and y-intercept, so y equal mx plus b. So here putting the contract should be the cost. C equal to m is 0.25 times m cos n cos. And then this n non. Okay, n cos and then plus $5 fixed cost. So that gives us the monthly cost based on the number of phone calls this person is making. Then we're gonna graph it using 2 points. There's a couple different ways of doing this. You can create a t-table, right? So this is what we call a t-table. Okay. You can just print when n equals 0, where there's 0 phone calls, then the cost is equal to 0.25 times 0 adding 5. That will be $5 cost. Okay. And secondly, we can create another order pair, right? So let's say n equal to 4, make it exact, right? Then when people is making 4 calls, then the total cost is 0.25 times 4 adding 5. 0.25 times 4, that's 1 plus 5, that's 6. We need cost $6 to make 4 phone calls. And then we just sketch the graph. So you can just x and y using the t-table 0, 5, when x equal to 0, y equal to 5. And we call this the y-intercept. Okay, so this is the first order pair right here. First point 0, 5. Secondly, when the it's making 4 calls, 1, 2, 3, 4 phone calls, then that will cost $6. 4 and 6. So using those 2 order pairs, 0, 5 and 4, 6. To sketch the graph. Now you connect those 2 points, extending in both directions, we get a line. And that's how we're using the t-table, creating a graph of the linear equation. So you can, if you want, you can label this y equal to 0.25 times n plus 5, right? I guess we can do c equal to 0.25 plus 5. So and here, n is the same thing as x, c is the same thing as y. Okay. All right, so that's basically how we graph the linear equation with the actual context. And also the last part is using a graph to estimate the cost of service in a month with 20 calls, right? So once you have the good graph, then you can estimate it from the graph. Algebraically speaking, here n equal to 20. That means total cost equal to 0.25 times 20 adding 5. 0.25 times 20, that's $5. Adding 5, that will be the total cost will be $10. From the graph, once you have this static graph, we'll be able to estimate that from the graph as well. Now, slope-intercept form. So we have 2 important elements: slope. Slope is right over 1, and then we have y-intercept, right? Where the line crosses y-axis. That's the meaning of y-intercept. Okay. And if you just want to use slope and y-intercept graphic, we can easily do that as well. And let's take a look at some examples in terms of graphing slope-intercept form. So linear equation reading in a form y equal mx plus b. is a slope-intercept form. Slope m, y-intercept m. And you can always put a y-intercept in the order pairs, so 0, b. The graph equation is in slope-intercept form. First of all, write the equation in the form y equals mx plus b. Identify slope and the y-intercept. Plot the y-intercept and then stop at the y-intercept. Find another point on line using the slope. And draw the line through 0, b and then the point located within the slope. I'm going to show you a detailed step here. So right here, we have example, graph the line y equal 2x plus minus 4. So here slope equal to 2. Then y-intercept b equal to 4. Slope 2, you can write it as 2 over 1. Rise over run. So since it's positive, on the numerator, positive denominator, rise meaning go up 2 units. And then positive 1 on the denominator, that means go to the right 2 units. Go to the right 1 unit. So what you want to do is plotting the y-intercept first. Y-intercept is -4, so -1, -2, -3, -4. So we're gonna get a graph, get a point right here. Now follow the slope, right? It tells us go up 2 units. So we need to go up to the -2 and go to the right 1 unit. So now go up 2 units, go to the right 1 unit. We nail down another point. So this point is 0, -4. Another point will be 1, -2. So by using the slope, we are generating another point. So based on -4, go up 2 units. Follow this procedure. Go up 2 units and go to the right 1 unit. So now connecting those 2 points, extending in both directions, we get a line. So if you want to label this y equals 2x minus 4, you do that. And always write slope in the fraction form. So we know the rise and run in this case. Okay, now let's take a look at this one. So graph y equal -1/3 of x plus 2. So here y-intercept b equal to 2. That means we get all the pairs 0, 2. The slope is -1/3. So this is the rise over run. So what -1 on the top means go down 1 unit. Going down is the negative direction. Going up is positive direction. Go down 1 unit. And positive 3 on the bottom is go to the right 3 units. Okay. Now once you have that, so we can sketch the graph. Start with the y-intercept 0, 2, 1, x equals 0, y equal to 2, 1, 2. Right here. Now from there, first of all, go down 1 unit. Go down from here, go down 1 unit, and go to the right 3 units. 1, 2, 3. So go to the right 1, 2, 3. Stop here. So the first order pair here we have is 0, 2. Second order pair that will be 3, 1. This point and this point. And once you have those 2 points and connect them, extend in both directions, we got it. So we get a line which is y equal to -1/3 of x plus 2. As you can see, since slope is negative, that means the line is decreasing from left to right. And we can easily verify that from the graph. From left to right, the line is going down. Now, so this is in the form. This graph is in the form -2x plus 3y equals 12. We call this standard form. So the equation appears in the standard form, and using xy intercept will be the easiest to do. I'm going to go show you detailed steps. Okay, so now in order to find the x-intercept, then we replace in y equal to 0 and solve for x. So when y equals 0 here, and go back here, this y value becomes 0, so negative 2x plus 3 times 0 equals 12. Now we can solve for x. 3 times 0 is 0, so we get negative 2x plus 0 equals 12. Now negative 2x equals 12, and divide negative 2 from both sides of the equation, and end up with x equal to negative 6. And this x-intercept is negative 6, 0. And then after that, we find the y-intercept. Okay, so in order to find that y-intercept, we set an x equal to 0. So here x becomes 0, so we have negative 2 times 0, adding 3y equals 12. Negative 2 times 0, that's 0, plus 3y, that's 12. So 3y equals 12. Now we divide 3 from both sides of the equation, and we know with y equals 4. Okay. So the y-intercept will be 0, 4. And once we have both x-y intercepts, so the x-intercept is located on the x-axis, it's right here. The y-intercept is located on the y-axis, 0, 4. You can just connect them, right? Mark those 2 points, connect them, we get a line. Okay. And which method is easiest to graph negative 3x plus 6y equal to 2? Similarly, will be xy intercept, but that would be the easiest one. And you can first of all find the x-intercept first by setting y equal to 0, solve for x. So we have negative 3x plus 6 times 0 equal to 2. So negative 3x equal to 2. So x equal to negative 2 over 3. Okay, so we get x-intercept negative 2/3 comes 0. Okay, the y-intercept, setting x equal to 0, so you get negative 3 times 0 adding 6y equal to 2. That means 6y equal to 2, and then y equal to 2 over 6, y equal to 1/3. Okay, so the y-intercept is 0, 1/3. Based on those two, we can sketch a graph. Alright, so let's quickly draw the graph here. X-intercept is located on the x-axis. Let's say this is negative 1 here, negative 2/3, we will mark split it into 3 equal parts. Negative 2/3 goes here. So we got the first order pair on x-intercept. The y-intercept is 0, 1/3, so this is 1. 1/3 is 1. Okay, so that's another point, y-intercept. And connected in extending both directions. Okay. Label this negative 3x plus 6y equal to 2. And if the linear equation written in a point-slope form, we can turn this into a slope-intercept form, and then we go from there. And also we can look at it like this. So if let's say we have an equation which is y minus 3 equal negative half times x minus 4. So that means slope is negative half, and then passing through the point 4, 3. So we can use 4, 3 first, graph 4, 3. Okay, get that point 4, 3, and then use the slope to generate another one. So the slope here is negative 1 over 2. That means go down 1 unit. Go to the right one, 2 units. So based on this 4, 3, go down 1 unit, go to the right 2 units, we generate another point, we get that point, and then connect it with the horizon. Now let's look at this example. Write the slope intercept form of the equation of the line through the points 4, 3, and then -2, 5. So given two order pairs, x1, y1, x2, y2. Now from here we can find the slope first. Slope equal to y2 minus y1 over x2 minus x1. Now replace y2 with 5, y1 with 3, x2 is -2, x1 is -4. So we get a 2 over -6. Now to simplify, we end up with -1/3. So slope equal -1/3, and we're using the point slope form y minus y1 equals slope times x minus x1. So now we know slope. We're given x1, y1. Slope is -1/3. x1 is 4, y1 is 3. And throw into the point slope form, so y minus 3 equal to -1/3 times x minus 4. And we distribute it, and we get a y minus 3 equal to -1/3 x plus 4 over 3. Then we're adding 3 from both sides of the equation, and we end up with y equal to -1/3 of x. 4 over 3 plus 3, so we can write 3 as 3 over 1. And for this fraction, LCD is 3. So multiply 3 here, 3 here. So y equal to -1/3 of x plus 4 over 3, adding 9 over 3. So y equal to -1/3 of x plus like fractions. Now combine the numerator, 4 plus 9 gives us 13. 13 over 3. So we get the equation in the slope intercept form, and we graph using the slope of the y-intercept. We talked about that earlier. And write the slope intercept form for the equation of the line through this point, and the slope 3. So this is even easier because slope is given here, so we don't have to calculate slope. And we are given the order pair -2, 5, and we know x1, y1. And so we know slope, x1 is -2, y1 is 5. Okay, so from here, let's use a point slope form y minus y1 equals slope times x minus x1. Replace slope x1, y1 with the given number, so y minus 5 equal to slope 3 times x minus 2. Just pay attention to the sign, make sure we have the right sign here. So simplify y minus 5, we get 3 times x, 2 negative to be positive, adding 2. And distribute it, so we get y minus 5 equal to 3x, adding 6. And from here, we're adding 5 from both sides of the equation. So we end up with the equation of our line, which is 3x plus 11. And that's the equation of the line in the slope intercept form. Slope m equals 3, y-intercept b equals 11. And next thing, let's check what is the graph of the y equal x plus 2. Here we know by default that's 1 in front of x, so slope equal to 1. Y-intercept b equal to 2. So we're going to check y-intercept b equal to 2 is either 2 or 4. And then if you look at slope is positive, meaning it's increasing line, so gotta be 4, right? So 4 is the right one. It's increasing line from left to right. You can also look at it as 1 equal to 2 over 2. So we move to the right 2 units, go up 2 units. Right? So that's how we use the slope to get another point. So y-intercept be equal to 2. So that's how I identify option 4 is the correct solution. The next few slides is a practice problem you guys can try on your own. Since you learned the method already, so I'm going to skip those. Okay, and then let's just take a look at the big picture. We have used 3 different methods for graphing equations. Slope intercept form, xy intercepts, and then the point slope form. 3 different forms. Which form is used to graph xy intercepts? Standard form. Right, one more time. Has to be standard form. Which form is used when slope is given at one point? Then will be point slope form. So the quick review of the linear equations from a graphical perspective. So given the slope intercept form, then we can graph using slope and the y-intercept. Standard form, we find the xy intercept and graph it using xy intercepts. Point slope form, we can use the point and then given point and then the slope. And we also will get a graph the line. That's pretty much everything on this section.